Hello everyone, welcome back. So in this video we are going to understand the longest balance substring 2, and this is LeetCode problem number 3714. Okay, so if you have tried this problem, right, so if your solution to this problem has passed for a small cases but failed on a big output, right, I can show you here. Let's suppose the test cases small are like this, okay, but there can be a big one also, this one. So these test cases will not work for most of the cases, right? Why? Because this is a big test case and it's very tough to pass this. But how we will work on that we are going to understand. Why this test case 4 will fail on the worst case? Because it give you the TLE, right, time limit exception on the big input like case 4. And if you're getting this, so you don't need to worry about this one, right? So I'll explain everything here, how to implement this type of problem. If you're looking for the code directly and not want to understand anything in detail, you can get from the comment below. And please like and subscribe the channel if you're new at the ExpertFunda. So let's try to understand. So this problem is not about sliding window, and it's about modeling correctly, right? So today I'll show you why the brute force will fail and why sliding window is wrong, why the prefix trick alone is incomplete, and why we have the final solution in O of 1 that actually works here, right? So let's try to understand here. Let's begin. So a very simple thing we have given is, we have given a statement at saying that it consists of 3 characters A, B and C, right? What are the characters we have? We have given a string with only 3 characters A, B, C, right? So a substring is balanced if all the distinct character in the substring appear the same number of times, right? Means the distinct character, we know that there will be only 3, A, B and C, right? It is saying all distinct character in the substring appears same number of times. Okay, this is what a substring is called balance. A substring is balanced if and only if all the distinct character appears the same number of times. This is what it is saying. The most important thing here is distinct, right? And we know what is distinct here. Let's try to understand simple examples. Okay, so as I told you, we have, let's suppose some example. Let's suppose we have A, B, B, A. So if I'll say the number of distinct element, what are the elements are here? So I'll say there is A is 2 times coming here and B is coming 2 times here. It means the distinct character here is A and B, and both are coming same number of times. What is 2 times both are coming. It means this is a valid substring which is balanced, right? Let's try to understand another one, A, B, C. If I'll take A, B, C, here A is coming 1 time, B is coming 1 time, C is coming 1 time. It means what? All the distinct characters are A, B, C, and all are coming 1 time, 1 time, 1 time. It means this is also a valid substring, right? Let's try to understand A. If I'll talk about all these characters, right? So these characters have only one distinct character is A, and these are coming how many times? 3 times, right? So it's fine. There is only one character, is coming only 1 time. So if only one char is there, it's also valid. Make sure that you are understanding. There is, here we found 2 type of character, here we found 3 type of character, here we found 1 type of character, and all these are valid here, right? Let's suppose if we have A, B, B, A, C. Here you tell me how many type of character are there. A, B on C type of character. It is coming 2 times, it is coming 2 times, it is coming 1 time. Means A is coming 2 times, B coming 2 times, C coming 1 time. But these are not equal number of times it's coming. If the same number of time is not coming, it means it's not valid, right? It's not valid. So you should understand when we will say the string is balanced or not. So a string is balanced if all the distinct character appears the same number of times, right? If same number of times is not coming, so it's not valid. Okay guys, so very first we have seen these examples, right? So can we say that we must return the length of the longest substring if we will find if this is valid one. So once you will find that, right, the important thing is here to distinct keyword, right? And then we have to return the length of the longest substring, and this is what the question is asking to us. So our question having the if you go to see the constraint, if you see that 10 to the power 5, which is n is less than equal to. So that is why we saw that the case number 4 test cases is big one, right? And that will not work. It will not survive for O of n square, right? If you keep checking the value, right, definitely you have to compare each element. You will do for checking all the element, right? You will go for O of n square, and that will not survive here. Okay, so why the most solution fails here? Let's try to understand. The very first thing is that let's test the string. If we have A, B, B, A, C, this test case we saw that it will fail because we have seen A is coming how many times? 2 times. B is coming 2 times. C is coming 1 times, right? These 3 things we have seen, which is not balanced, right? So but if you use a simple prefix appearance for A and B, right, let's call it, we will take A and B. So the prefix difference, let's suppose count A and B. So if you count A and B, you know that this is our count, right? So this is called prefix. Let's suppose prefix. And if you want to find the prefix difference is what? A what you call the count, can say count of A minus count of B, and that is coming 0. If it is coming 0, so you will mistakenly accept the whole string, right, of 5. If you take the length of 5, right, so if you accept the whole string of length 5, right, so that's the wrong thing. Okay, because you forget 2 character balanced substring must not contain the 3rd character, correct, as we have seen here. So that will be the trap. So in that trap we should not go. If that trap is coming, you have to avoid that. Okay, so what is the idea here? So you should understand the idea is that since the string contains only A, B and C, A, B and C, right, we have seen. So if the string contains, give me 1 second, if the string contains A, B, C, right, so balanced substring can only be a single character, that we have seen the previous example, right? Let me show. Okay, leave it. Let me clean it, then we'll understand. Okay, so we have seen that A, B, C, the string contains A, B, C 3 characters, right? We have seen, as you can see here, right? So the balanced substring can be of single string, that we have seen, single string. It can be 2 string A, B, like that, 2 string character with the equal counts. There can be a 3 string with the equal counts. It can be A, B, B, C, C like that, or anything, any combination will be different, right? Means all these 3 character is possible, but the counts should be equal, right? Counts will be equal in all cases, right? So if there is only one character can be anything, it doesn't require these equal counts, right? But in these 2 cases equal counts is required, right? So there are 3 structural cases. Instead of the brute force substring, we solve each case mathematically, right? So let's suppose that we have a case. Let's suppose the case 1 we have in which I am talking about the single character, right? Single character. So just find the longest consecutive run. How? Let's suppose we have A, B, B. So we know that we will keep going here, right? We have BB here also. So what is the longest run here? So we'll say the longest run for 3 character, as we know, is 3. It is taking O of n times, right? Let's suppose for the 2 character, let me clean it. So in case 2, let's suppose we are saying we want 2 characters equal, right? It means we have a combination AB, there can be other combination is AC, and other condition is BC, right? These 3 conditions. Now here the important trick is we have a pair of AB, right? So we must ignore the segment containing C. Okay, so when we find the segment that contains C, we have to ignore that. So we have to split by C. Always split by C. What I said, for any pair AB, right, we must ignore the segment containing C and split the string by character C. Okay, so this is what we should understand while doing that. Let's suppose I am talking about A, B, B, A, C. So we have to split by C. So we will split like this. So this character and this character, 2 substring will be there, right? So once we split by C, so these character will be here, right? A, B, B, A. So now inside each segment we will use the prefix, the difference. How? Difference. So we'll say count of A minus count of B. This will give you 0, right? So if the same difference appears twice, the string is balanced, right? So if difference is coming 0, it is balanced. So this works perfectly because the third character has been removed here, right? And we repeat this for all 3 pairs. That is become the O, and the character is 3 times, so we will take O of 3n. So this will also work as O of 1, right? So this become the time complexity for this type of cases. Let's think about case number 3. So case number 3 we have is, let's suppose we want all 3 equals, right? So now we want is A equal to B equal to C, right? So the classic difference is what? We have 2 differences. Let's call difference AB and difference AC, we can say that, right? This is exactly same. So we'll say A minus B, here we'll say A minus C. So if the same pair we have, right? So pair is what? If the same pair, we will say is pair is difference AB and difference AC. If this difference appears twice, how many times? If it is 2x time, means appears twice. That means A is equal to B is equal to C, or you can say A double equal to B double equal to C. We can say that. Okay, why? Because the difference didn't change. This is a pure prefix hasing, we can say that, and it will take the O of n as a time complexity, right? What did it say? This is a pure prefix hasing, we can say that, prefix hasing technique. Okay, and it takes O of 1 as a time complexity. It means, if I'll summarize everything, guys, so can we say that for the final time complexity, if you use the single character, right, it will take O of n. If you are using 2 characters, right, it will take O of 3n, that we have seen. If we have taken 3 character, we will see that it will take O of n as a prefix hasing technique, pure prefix hasing. And if we'll talk about the total, right, so total TC is nothing but O of n, correct? If we'll do all the sum, it will take O of 1. So this will pass O of 5 as a time complexity, it will work for, it will pass for the 10 to the power 5 as a time complexity easily. Let me show you the code so you will understand. I'll put this code into the comment box. Please get from there and try to debug. So very first we have seed for the single character, guys, and then we will do for same, we'll do the same thing for the 2 character and for the 3 character, and we'll return this. Okay, and these methods we have already developed for longest single chars, solve 2 characters and solve 3 characters. So if you come here, you will see the, for the single character, we'll check like this. We'll check, we'll go for the character, we'll check with the previous character. If the count is increasing, right, it's fine, otherwise we'll make the count else. If all the character are same, in that case count will be get increased. Let's suppose A are there, right, single character, so we'll return here the max value from here. Okay, you have to track the max value of the count, you can say that. Okay, similarly, if 2 characters are there, we know that there will be 2 characters, right? So characters, the string is given character X and character Y, A or B, we can also say that, or B and A and C, we can also say that, right? So we know that this will take O of 3n. So how we'll go for that? We'll create a single pass for each string. We'll check if string contain the split character, right? And then we'll say, okay, what is the split character? Is that C will be the split character, right? Then we will split that and we'll find the max length. We will iterate, and it will, each time it will say I plus 1, but we know that I minus 1, and this is the start. So we want to solve the segment basically, and to solve the segment, we know that we have already created another method that is called solve segment, right? So you have to go for this method where we have to create a mapping, means we want a pure prefix hasing, right? And for that you need to create a map, and for each character you will check if it is on the character, you will find the max length, otherwise you will check if character is X, keep difference plus plus, else difference minus minus. So you know that the difference will keep happening, and for each thing you will need to create the max length, and you'll keep putting the max difference there, and you finally return the max length. Coming back to the 3 characters, you know that 3 characters will be there, so we'll take A, B, C as all these values, right? And we'll define for all the for loops, for all the elements we'll create a for loop, and each character you will check, and you need to find the difference AB, difference AC will find, and you will make this as a key. Okay, then you will check the max length like this. So you will iterate over the map, you will check if the key is available, you need the max key, otherwise you put this key into the index, and then you will return the max length. Basically, overall, if you talk about what we have done, we have created 3 cases: single character, 2 character, and 3 character thing, and we will return the max length. Okay, so I'll put this code into the comment box, guys. You do some surgery over this code, try to do debugging, try to write some console message, and try to understand what the question is saying. That in case you have any doubt, let me know so I can create a deep dive session, and I will make some extended video of this solution and we'll discuss over there. For now, that's all I have in this video, guys. So if you have any doubt, you can bring me in the comment box. For the interview perspective, what we can say that if the alphabet size is small, right, the enumerate subtypes, if the condition involve equal frequency will be there. So think prefix differences. If subset matters, you must isolate character domain, and that is the real trick, we can say that for now. Okay, so if this explanation helped you, like this video and comment balanced if you understand the prefix trick, and please subscribe this channel, and like and share this video with your friends who is doing preparation. And if you are struggling with the DSA preparation, you can join my online classes, and for that you need to contact our WhatsApp, and we'll schedule the call. We'll go from there. Thank you. Bye bye. See you tomorrow.